Hello. I'm just eating some lovely pretzels. Where do I put my mic? Oh god. I'm gonna put it here. That's not gonna be good, that's gonna be bad, I think, but I'm gonna leave it there. Save me, Capo, you does math. Save me. So real, so true. I can do that. Can you eat next to the mic? I did one French. Bleh. I killed your mic? No, I turned it off so you wouldn't hear my crunching. It's not, I can see it's not going demon mode, so we didn't summon the demon with that one. Luckily. I did this one wrong. This is wrong. This is partially wrong. Which is really depressing. But doing it right should hopefully be a lot better than whatever I just got at the bottom here. I say hopefully, because maybe it won't be. I don't know. But, okay, so how do I describe this course? So this is the follow-up to the linear algebra and differential equations course that I did. It's we do some stuff like Fourier transforms and Laplace, a Fourier series, Laplace transforms. But it's really meant to solve a very certain subset of differential equations that are used for vibration analysis and for heat transfer analysis. So it's a very narrow class, but there is some stuff that you learn. It just so happens to be a very sort of engineering class. So the first thing we're doing is power series solutions to differential equations. So the idea behind that is we take y to be some power series that we don't know, and we can differentiate that to get our other derivatives of y, like this, and n minus 1, x minus 2. And then we can put all these into this equation that we have. We can end up with a bunch of stuff, and then we can combine them into one series, and then we can say that because this needs to equal 0, we have some power series. Let's just say like x, and then it's an, and x to the n. This is just some term of an's. If this is equal to 0, then each one of these coefficients has to be equal to 0 for this to be true. This is actually the 0 polynomial. So we have to set all these equal to 0 for that to be true, and that means that we set our an equal to 0, and we get what's called a recursion relationship. And then we can solve for these coefficients, because that's sort of what we want to figure out. We want to figure out what our solution is by getting coefficients, and this is going to turn into a function, essentially. And sometimes it's a nice function, sometimes it's a not nice function. Most of the times it's not a nice function, and we'll need to use an approximation. And it's just going to be some really long guy. That's not really particularly anything, but it'll be the solution to our thing. So there are some things that we have to like figure out if we can use this method for. But first we have to get it into standard form. This is not standard form, so we got to divide everything by, we want to have nothing in front of the y double prime. So that'll be 1 over x, and this will be x squared minus 1 over x times y. I'm actually going to write that as x 1 over x y. Make it a little easier to do that. I say it makes it easier. It's not going to be too different. It's exactly the same thing. visually, I think for you guys, maybe that'll make a little more sense when I start to split stuff up. Okay, so now we can say, all right, we have to ask the question, are these coefficients analytical? So these are functions, this is p, this is q. And for them to be analytical, it just means that they have to be smooth, right? They have to have infinite derivatives we can take. And both of these are that. So we can just keep taking derivatives of these, and it doesn't really matter what our x is, although we have to say x can't equal 0. So at x equals 0, actually, okay, that's kind of an issue. Because if this was if this is like x minus 1 or something, and x like couldn't equal 1. Okay, this is making me rethink things. Wait, this isn't x, this is x squared. So this is 1 minus I. Okay, I've already ruined it. But this is, okay, the reason why this is kind of an issue is that means that it's, like what is it called? It starts with an O. Wait a second, what is it called? Maybe I didn't write it down. There's a high chance I didn't write it down. Where is this? N equals 7. That looks like what it is. That's really bad though. Because that means that it's not good at our point. Because normally we solve things for 0. What's up with that? It's a singular point. It's not ordinary. What happens if it's, I don't know what happens if it's singular. Maybe I wrote this problem wrong. Maybe, let me check. Let me check if I wrote this problem wrong or not. Because that's, not supposed to happen, I don't think. On the, like, first problem that we have to do. What a silly little thing. Maybe it is that, and he's trying to trick us. He's like, oh, they're actually not. It means that the solution won't hold true that we find at that point. Because like x is 0, right? So like how you can't divide by 0. Show that, oh, x squared minus 1. They meet, that's not supposed to happen, VTutor. Yeah, that's accurate. Wait, but it says show that f is the solution to the differential equation. Excuse me. Okay, fuck it, Weeball. I'm gonna do a different one. I don't have time. It's Davey's first time. Yeah, that's accurate. I have to print out this whole thing, by the way, which I'm really not too particularly pleased about. And they all have to be on their own paper. I can't cram all of them onto one piece of paper like I normally do. I hate having to waste ink. Okay. We could do this one. We could do this one. Look at how nice this is. Look, it's already in standard form. This is analytical. This is analytical. Nobody's mad. We're not. When x is 0, we're chilling. We're great. You can find a radius of convergence really easily. Okay, here we go. 1. Substitute that and find a recurrence. Okay. So I'm just gonna skip right to doing this. So n2 an times n minus 1 x to the n minus 2. And I'm changing this because, I mean, you can think about it sort of two ways. The first two terms of this are going to be 0 because we took the derivative twice, and on the first time we take it, there's a constant in front, and so that'll give us 1, 0. The second time we take it, there's another constant in the front, that's another 0. Or the way that I also sort of like to think about it is if this was n greater than or equal to 0, we'd have like x to the minus 2. And that's not, I mean, the coefficients would be 0 there, but also like, I don't like that that exists because that's not part of our power series. X minus 1. Okay, now we have to add this 2x in here. So it'll be 2 an minus 1, and then we add an x. That should be n. Already making mistakes. And then this one is going to be 4an x to the n equals 0. Gonna get very long equations up in here. All right, so this is gonna be, I'm gonna just write that as n, because it's gonna confuse me. So we need to reindex this first one. So for us to be able to add sums, we can add we can't add anything. In order for us to add sums, they have to have the same power of x and the same starting index. So none of these have anything, right? Which is great. I love that. So we need to reindex this one first, and then we can pull out terms to do that. Okay, so this is going to go down to, or sorry, it's going to go up to, so this will be n greater than or equal to 0, which is lovely. an plus 2. And I'm reindexing to, for n equals n plus 2. So I'm using the same variable. And then we're going to add 2 to this, so 2 minus 1, n plus 1, x to the n. And this one we'll have to orphan a term, but I'll do that on the next line. It's a little easier to see. I mean, I could just, yeah, well, it's not that long right now. Okay. So we got all these boys. It's good. I am just going to write this here. Actually, okay, I'm going to do this. I'm going to skip. Okay. I like to split up the orphans. It's a crazy thing. So, remember I said that we have to have the same starting index to add up sums. So what we're going to do is we're going to turn this, oh fine, I'll do it out. We're going to take out the first term of, these to get them equal to n. And the terms that are in front are called the orphaned terms. So we're going to take out the first one. So for n equals 0, that's going to be 4 times a0 times x to the 0. So that's n greater than or equal to 1. And then for this one, it'll be a2 times n plus 2, which is 2, times 1 times x to the 0, n greater than or equal to 0, a n plus 2, n plus 2, n plus 1, x to the n plus, there we go. So now, what we want to do is we're going to split the orphans and the other stuff. So when we factor this out, we're going to be able to factor out all of the orphan terms. So it'll be 2a2 plus 4a0, and that has to equal 0. So essentially we get something like orphans times the sum of n, in this case, it's 1. Nobody yelled at me for that. Davey does what? an x to the n. And so in this case, we need this to equal 0 and this to equal 0 for that to be true. I'm sorry, that's just what they're called. And then our sum is going to be this. So we get sum of n greater than or equal to 1. That doesn't matter. We're going to pop all these out. So a n plus 2 times n plus 2 times n plus 1 plus 2a_n times n plus 4a_n. That's it. 4a_n times xn. So if we write this again, I mean, I'm actually just gonna, so this is our recursion relationship. I'm gonna solve for the highest term. So we're gonna solve for a_n plus 2. This is gonna equal negative 2a_n times n minus 4a_n, and then we divide by n plus 2, n plus 1. So now we can say, okay, for a_n plus 2, we get this thing. I'm going to re-index it so that we get when we plug in like n equals, sorry, this is for n greater than or equal to 1. I'm gonna re-index it so that we can plug in n and get the a-nth term. So in this case, we're saying n is gonna go down 2. So negative 2 a n minus 2, n minus 2, minus 4. Wait, I can factor these out. This is 2n plus 4 times an. Oh, so it's just 2 times n plus 1 an. It's nice. He's abusing orphans. What a perfect specimen. No, no, guys, I swear. They're so useful. Look at this, look at this, look at this. We're gonna say a2 equals to a0, and we're gonna use that. They have homes. They're all friends, see? Did I do that right? Nope, I did not do that right. 2n plus 2. Me when I said 2 is 4. So keep the 1. Rid of that. Okay. I feel like if I lived in the 30s, 40s, I'd be 100% doing human expiration. I'd be expiring people. I think that's just called killing people. I would not be killing people. Or do you mean experimentation? I don't think I would do that. That's like too scary. Okay, n minus 2. So then we have n minus 2 plus 1, so n minus 1. And that's for n greater than or equal to, so we're going down 2, so n greater than or equal to 3. Thanks, autocorrect. Experimentation. No. I think I would be doing machine stuff. I think I would be like, what would I be doing? Okay, 30s and 40s in America. Wasn't that like, that's World War II? Yeah, I was supposed to say, wasn't that, I'd probably be having a miserable time because I probably wouldn't want to work on war stuff, but I would probably be working on war stuff as an engineer. Okay, so now we get to solve recursion. So for n equals 3, we have a3 equals 2 times a1 over n Maybe that's okay. That seems like it's weird. Over, okay, n minus 1 is 2. So then I'm gonna skip to a5. I guess I don't really need to write that. This will be 2 times a3 over 4. It's gonna be 2 times 2 times a1 over 2 times 4. a7 is gonna be 2 times a5 over 6. 2 times 2 times 2 times a1 over 2 times 4 times 6. Okay. It's like enough for us to get a pattern. So we definitely have 2 to the n. 2 to the n, a1, over 2 times 4 times 6. That'd be like 2 times 4 times 6 times 8. Factorial of 2n. 2n factorial? No, I don't think so. It's not 2, it's not like 4. Oh god. That's like scuffed. What am I supposed to be doing? Just finding, I guess, an answer to this. Oh, maybe it's, wait. So how do we get 2 times 4 times, how, like 8? So we plug in like, we plug in 7, we get 6. Okay, so first off it has to be like n minus 1 factorial. Minus. n minus 2 factorial? No, that would clear out all the terms. I just need the odds, though. Oh, how do I get just the odds? That's so hard. It's definitely, it has to be some sort of factorial. 2 times n factorial. Because this is 1, 2, 3. Okay, it's not n. N mod. N over 2 minus 1 factorial? Does that work? Is that right? Okay, so like we put in, let's put in 9. I was so worried there. I thought my entire computer crashed. It's because I got too good of a right answer. I was too on track. They had to take me out. Okay, so this is gonna equal 2 times, this is 2 to the 4th, a1 over, okay, so it's not 2 to the n. 2 to the n over 2 minus 1, yeah. 2 to the n over 2 minus 1. You know, that classic number. Oh, that's so scuffed. I don't actually even know if, like... Because this will be 1 through 4, and then n over 2, 9 divided by 2. Oh no. I have to, like, floor it. Can I even do that? I don't think I can floor it. Oh no. Oh no. N divided by 2 minus minus 1.5. Oh, you know, that classic number. My best friend, N divided by 2 because they're all odd. So like, if it's like 3, you divide it by 2, you get 1.5. That's wrong. I need that to be 2. What the heck? How do I do that? Wait. Wait, no. Wait, 3? No, it needs to be 1. So 3, it has to be minus 0.5? Or minus 1.5? Is 5 divided by... Oh no, it's just 0.5. I'm silly. 0.5. There we go. Oh, you know, just a classic series. That's it. That's our series for that one. We have to do the other one now. A0. Can I do A0? I don't think I can do A0. Sorry, A4. Equals 2 times A2 over... Well, I guess I should put in A2 first. We use our orphans. A2 equals 2A0. Oh no, yeah, we're chilling. So 2 times A2 over 3 equals, so 2 times 2, A0 over 3. 2 times A4 over 5. Yeah, we can kind of see where this is going. So... okay, so 2 to the n over 2, I think. I don't think we have to do the minus. Times A0 over 2 times... Now, is it 2 or not? Because, so... Oh, it's, oh, that's, oh. Oh, we can't do it like that. Ugh. Okay. Okay. How do we get 3? What is 3? 3 is 2 times 1.5. We can't do like a factorial with like 1.5 though. We could say... Could be 3, 5, 7. Hi, hey Scribble, how's it going? Scribble. 3, 5, 7. How do I get 3, 5, 7 out of a factorial? Oh my god, my brain. Okay, we have to start with 7. Maybe we don't. We probably shouldn't start with 7. What if I divided the factorial by a different factorial? Then it would get rid of the terms. Sort of. Not really, in the way that I want. Okay, 3. What if I did 1.5? So 1.5 would be 2 times... It's 5 divided by 1.5. I'm looking. I'm looking. 5 divided by 1.5. No! It's not even. Okay, we can't use 1.5. About 5 divided by 3. No, it's not good. How the hell are you supposed to get this? Maybe he's not expecting us to do it. Okay, not do it. I don't mean do it. I mean, maybe he's not expecting us to write out a nice relationship for it. Use the recurrence relationship considering even and odd ends separately to find a form of the solution where A0 and A1 are arbitrary. We're so close, gamers. If I can just figure out how to do... I'm actually trying to attempt the image I sent you. Oh, let me take a look at it again. It was a series thing, right? Just something series. Given the set A, find the permutation for which it applies that pi times k minus I. Concatenate every element of p, turning all double-digit numbers into that, then reverse the string. I don't know where to begin. Okay, I would probably do this in MATLAB. I would just because I've been using it for math stuff and it's pretty good for math stuff. I would first make a vector for A, or an array, that contains 1 through 13. And for a permutation P, we're saying that the sum of those is approximately equal to 0 times... Wait, to 0? To 0? Why would it be 0? Hello? Pi... Okay, so like... I would set up a sum, I guess, of that. Or like a loop. And then... just loop through all the different permutations. And then figure out which one is closest. There we go. That's what I would do. Would it take a long time? Probably. What is that, 13 to the 13th? Computers are fast. I don't know how to do this. It's very likely that I did this wrong. And that's why this is wrong. So maybe let's do a different one. If I did one tiny little algebra mistake, then it is wrong. Come on, this one should be easier. Find the first non-zero terms, first 5 non-zero terms. Okay, that's like so cute. That's so cute. I don't know why I copied it. I don't really need to copy it. I'm just really used to copying stuff. Me when I love copying and pasting. Also notice, oh, you wouldn't notice. I haven't done 3 yet. Wait. Oh yeah, it's because 3's kind of weird. I meant to, oh wait, I can actually ask him. 3 is like too easy. I don't know why. I don't know why it's so easy. But I feel like that I'm doing it wrong, because it's too easy. Okay, so it's y double prime plus xy. Okay, we're good on that. Everything's awesome. Let's just write it out. n minus 1, x to the n minus 2, plus... Okay, I just, like, my brain stopped for a second there, because I was thinking about another problem. I was like, what if I didn't write it like that? But no, that's because... I mean, I guess we could just try doing this one out, but I also don't want to do that. Anyway, I don't want to do it without having the points. If the point's ordinary, that'd be bad, is the thing. Anyway. It wouldn't be a Damien stream without the Mike Demon. Sorry, I had to go. Good, you missed the Mike Demon. Oh. What was that? Sorry, that was my demon. I'm gonna turn my mic down a little more so it's a little less demony. This feels wrong also. I feel like I'm doing something wrong. I'll do a book problem to see if... What did you name the Mike Demon? I think I named him Rho. Like Rho, like density, because like for the Pharaoh's curse. I'm cursed by a pharaoh. And so I must atone for my... You know, the frustrating thing about this is that I know it doesn't happen on my PC. And so it's a software issue or something. So like, what is doing it? I have to I'm gonna like uninstall OBS and reinstall OBS. I don't know. I can't do it anymore. I can't, guys. I can't. Okay, I have to find these terms. These are probably gonna be bad. I almost said a bad word there. n-2, 0. I don't know why I thought that was something else. It's literally given for n greater than 3. Okay, now we can do something. Negative a1 times 1 over 3 times 2. My brain is rotting. I miss suffocating people in the mine. Oh, you... Wait, what? What is that? What is that a reference to? Suffocating people in the mines. Oh god, wait, that's 0. Oh, it's gonna be so 0. Oh, oxygen not included. I actually was playing it earlier because my brain was also rotted. It's so fun. Actually, except that on the new save I started, I don't have a dupe who can do research. No one has the researching skill, and it's taking so long to research, and it's pissing me off. I'm like, ugh, I need to research. We're gonna die if I don't have them research. I might have to play it. I might have to play it soon. Teehee. Because it's really fun. Have you checked the... Oh, I have not checked out the Shapes demo. Oh, I forgot, because it was on my other computer. I will have to check that out for surezies. Oh, you're gonna give me more brain rot is the thing. I'm gonna want to play it, and I can't... I have to do my work. A4. Okay, so this is negative A2. Oh, that was 0. Oh, back off. Are you kidding me? These are gonna be so 0. Wait, there's 0 every other one. Oh my god. 1, not the Shapes 2. It's just on Google. I missed it, and I'm angry. Wait, missed what? It took me enough of these to realize that that's what that was. Oh wait, I remember him talking about this. He was like, there's a pattern on triplets. I don't know what the triplet pattern is, but there's pattern on and off. Wait, where's A1 going is the issue. Oh, A1's in A3. Got it. Wait, where's A0? Uh-oh. Wait, no, A3 should be... Wait, A2's not 0. Wait a second. No, it is. Wait, so A0's just not in there. It's bad. From 2D to 3D sort of elevation, like Risk of Rain? Is Risk of Rain... What is Risk of Rain? That's not like the deck builder roguelike, right? That's like Spire, Steal the Spire or something? Risk of Rain is a roguelike? Where's my A0 going? Guys, I'm losing it. Wait, for n equals 2, it would be 0. Which is the only way we could have A0, so A0 can't be in here. Unless I did something wrong. Which, you know, is true. Slay the Spire. You're using medieval ass weapons from the 19th century? With Bungus. To triple the bunkai. I feel like I'm doing something wrong. I'm losing my mind. Okay, maybe we do a practice one so that I don't like, I don't make a fool of myself. I don't make a charlatan. That is actually a very apt word. You know, you ever hear like I read a lot as a kid. You ever like have a word in your brain and you're like, yeah, charlatan, I know what that word is, vaguely. I know how it relates to other English words, but you've never like really looked up the definition because you just like know it contextually. I had a 40 stack in non-command. I don't know what that means. Okay, about it. Wait. They're both analytic. No, it's a singular point. Yeah, it's non-ordinary. And that sucks. We see by inspection, all other points are ordinary. That was just a noise that I made. That wasn't a mic noise. Man. Okay, let's just do an easy one. I can do these though. I know how to do these. I don't know why I'm like tripping. Maybe I do 5. Wait, 5. Wait, 5. Wait, 5 is the answer. Wait, 5 is this question. I just want to see if I have an A0 term or not. I should have an A0 term. Risk of rain yapping. You wouldn't understand. I miss playing video games, man. Answers to odd number questions. Let's try 11. 11. 5. 11. 11. Sorry. 5. 1 plus... What the heck? What the heck? Why is there no A0 in there? Oh, 1. What? Oh. You know what? I don't like that. Play DSP? What is that? I don't know what that is. Okay, maybe I should check my math. Maybe I should, like, check my math and not just, like, keep steamrolling through all these. Or I could do 1. Why are all these so hard? That's really a bad thing. I really should do these until they're not hard. Deep Space Galactica. Kerbal Space Program, but less complex. Well, I should just play Kerbal. I don't know if I have Kerbal or not. Wait, I'm looking. I'm trying to scroll. I do not have Kerbal. I thought I had Kerbal Space Program. I love engineering games. They make me go brrr. Okay, let's check. I'm locked in. Okay, when we take a derivative, it's power rule twice. We did that. Good, I can take derivatives. This goes up twice. That's good. This is right. We add 1 because of the x. Good. Okay, we re-index this. N goes up to here. That means this goes down to. This is n equals n plus 2. N plus 2, and then minus 2. Okay, good. This is right. N plus 2, n plus 1, n. Good. I didn't do anything. Dyson Sphere Program. Wait, that actually that's such a cool name. We orphan term from this one. It's the n equals 0 term. 0, A2, 2, 1, x0. What is up with that? It should be fine. It should be fine. 2a2 equals 0. Oh, wait, did I like... Wait, I knew that, though. That's really an issue, though, because it means that I don't have anything. What the heck? Yeah, I'm gonna get zeros every third one. Wait a second. A3. Okay, let's be very careful here. Or maybe it's with my recursion that I messed up. Okay, I wrote that there. Wrote that there. Okay, good, good. I move this to the other side. It's a negative. Doesn't really matter, that part. That's all good. N is greater than or equal to 1. This needs to go down 2. So n equals n minus 2. N minus 2, n minus 2. That is 0, and that is negative 1. Should I go play a mercenary returns run? Yeah, go for it. And then that goes up. Okay, I did it right, though. Why am I getting it wrong? Okay, A3 equals negative A1 times n minus 2, which is 1, over 3 times 2. You should loop till you find a shrine of order. Oh. Equals negative a2, which is 0, is the issue. That's the face that I'm making. Those are my cat ears. I'll be a little more worried. This is my progression. Can't shoot in the opposite direction you move. You have to move towards danger to shoot it? Well, yeah. Aim with your mouse. Oh no. We're seeing someone realize. This is not gonna work is the issue. This is A2. It's 0. And then if I go A5, it's gonna be negative A3 times what? Times 3 over 5 times 4. And then A6 is gonna be negative A4, which is 0. How the heck am I supposed to get anything else? Do I not? I only get like A1 terms, and the other rest is garbage, it's 0. I did an oopsie a couple minutes ago. What's the oopsie? I do oopsies all the time. This is an oopsie. I also really don't want to do this one. Oh, don't make me look at this one. This one I did wrong probably too. This one's gross. I'll allow that message. It was held because you said bitches. I think it's funny. And then me, male. My curvy booty on accident. I'm just imagining like the surface, sinusoidal, a curve. The fluid flow is unsteady. Why are all these so hard? What's 2? Oh, 2 is this one! 2 is this one! 2 I should be able to do. 2 I should be able to do. 2 I should be able to do. 2 it. Show that f of x is a solution to the ordinary differential equation. What if I don't divide it? I have to divide it though. I can't just like not divide it. I have to divide it. And then if it's... Am I just like dumb? But it like wouldn't work at 0 if you divide it. That's like the first step. If you look at this, you can't put x equals 0 in there. What happens if it's singular? What happens if a point is singular on a differential equation series solution? The solutions can't be represented by a power series. It's in the 4th dimension. Oh, I can't wait for Risk of Rain 3. In the 4th dimension. It's an irregular singular point. Wait, x squared over x squared. Since... Oh, wait. Oh, I see. I see what I did. I see what I did. Do you see what I did? Wait, no, I don't know if I can call this one. Okay, I think I see. Technically. I actually don't know. So, has a singular point? No, yeah, you can't do that. As x equals 0, it follows that x is a singular point. Yes, you can't do that. Wait, what? This is... I'm losing my marbles, guys. Am I supposed to not... Sorry, I saw the word Frobenius. There's a different way of solving it if it's singular. This is like the most singular thing I've ever seen. It's literally 1 over x. You can't have a 0 there. Did he say like centered at 1? He said centered at 1. Maybe we'll be chilling. Show that xf is the solution to the differential equation. What? Excuse me, what? Hello. Hi. What? It's singular. Does he just want me to solve it even though it's singular? Because it would not be a solution to the differential equation. I'm so confused. Let me stare at it. Okay, it's literally from n equals 0. It starts at x. It doesn't start at constant. How do? Wait, BRB, yeah, take your time. I'm just gonna stare at this for a little bit. Maybe we just try and solve it, but I don't think I can solve it if it's like this. Okay, fuck it, I'll just solve it like this. I got time. Fine, okay. Sorry for writing this thing just a bajillion times. So this is gonna be n times x to the n minus 2, actually. And then plus... Okay, there's gonna be 2 of these, so one of these is just straight up an x to the n, and then I'm gonna do the other one as well. Minus n greater than 0, an x to the n minus 2. Okay, they're almost all n minus 2, which is like... I should probably just not do that, because it'll be more confusing. Oh, it doesn't really matter. Yeah, it kind of does, whatever. We'll just do it. I'll reindex everything to n. So this is n plus 2, so this is n greater or equal to 0. Hey, you like seeing this over and over again? It's literally just... I mean, I could just remember this at this point. It's faster. Oh, sorry, n greater than or equal to -1. Not sure how I feel about that. That seems wrong. But we are going to continue forward, I suppose. You know, just keep moving forward into the storm. Okay, this is gonna go up, down 2. -2. Whoa. We gave an infinite amount of monkeys an infinite amount of time with an infinite amount of typewriters. They were one day write the answer to this equation. So why solve it? Figure out how to extend the universe's lifespan by infinity and clone monkeys infinitely and clone typewriters infinitely. And each typewriter see if they check the if you wrote the answer. How do you check this, if they may ask? Wait, but if they wrote the right answer? But you wouldn't know if it's right or not. You would have to just do the problem anyway. You would. You would know if it's right, because they wrote this is the right answer at the end, but what if they were lying? I have to reindex all this. I think I'm doing this wrong. Let's do one that you know what, let's do one that I can check the answer on, so that I can make sure I'm doing these right. It'd be really quite... The thing that is like wacky is like I'm pretty sure I'm doing them right. Like, okay. As 2 linearly series centered at that. Oh, I see. Okay, we'll do this one. I don't know why I'm taking a picture of it. I can write it. It's really fast. Okay, this is a practice one. You just keep looping fair. Okay, 1 plus x squared. Okay, I got scared for a second. I saw an x squared and I went, oh. But we're okay. Okay. So, first we have to put it into the right thing. Everybody loves putting stuff into the right thing. Here we go, right, standard order. 3x plus 3 over x, y. Now C, there's not an issue here because, wait, yes there is. Is that not count as an issue? When I split it, there's an issue. But if we say 3x over, I want to see what they say. It's 1 over, so 1 plus x squared, right? That means that x can't equal 1. Wait, no, it's fine actually, because it would... No, it's always positive, so that's not going to be an issue. But it's an ordinary point. It's an ordinary point. Yeah, it's not a singular point. But if you split it, then it does. What? So you can't split it. What? Okay, wait, this one's doing it with summation. Okay, that's the first rule of thumb. Wait, so then the other one is okay because I don't split it? No, but it's x squared! Dude, what? I don't understand how that one can exist. Unless it's a gotcha. I feel like there's no way it's a gotcha. Look for the answer in the library, which will require you to know the answer. Well, it wouldn't require you to know the answer. You could go to a solution manual and figure out the problem number and figure out the manufacturer and assume they're not lying to you. That's how you could do it in the logical sense, but I don't want to do that. I want to figure it out. Okay. This one's already set up. Wait, this is also isn't this one of the questions we had? Wait, am I tripping? Is this not like 4 or something? This is 4. Oh no, it's slightly different. Okay. It's very... No, it's the same. It's the same. Wait, why is he giving us homework questions that the answers are on the book? Wait, that's so funny. I mean, I'm not gonna use the... Well, man, I didn't... Okay, I'm gonna do this one. Wait, I can just check to see if I did it correctly here. Wait, but that's like, I feel like that's kind of like bad. I feel like that's kind of bad. Wait, they do have... differentiating. Okay, we did the differentiation right. But let me just see if my recursion... Okay, my recursion is right. Ooh. Wait, it's minuses. Does that matter? Did I fuck that up? No. Oh, theirs was both minuses. Ours was both pluses. Okay, so mine is fine. Although it should be a minus on the other side. Did not do that. There. It doesn't really matter, is the thing. Also. Oh no, I put a minus out in front of everything. Oh wait, no. Oh, it's gonna alternate. Oh. That's so scuffed. Okay, there we go. -1 to the end. There we go. I don't know if it's n. Fuck. I also don't know if... Wait, when they split theirs, do they call this one like one variable and the other one another variable? Let's see. Two over k plus 1. 2 over k plus 1. Did I goof it? Oh no, they didn't do that. 2n over 1 times 2 times 3 times 5 times 2n minus 1. Wait a second. I did that. Oh, they just didn't want us to give a thing. Okay, no, so I didn't do it wrong. It just is gross. Wow, that's kind of wacky. Okay. Well, I mean, I guess maybe that makes me feel mildly better about myself, but not really. I don't know. I don't know how to feel. I feel betrayed. So I just tab back into Discord and this giant, scary yellow face is smiling at me with the red eyes, and I don't like him. He's really big and scary. Wait, let me... Okay. I'm going to... 1 second. 1 second. Let me just say 1 second a couple times until it becomes not 1 second. Let me rummage. Okay. So we're on the right track. We just aren't getting the answers. And this is not really the way that we should write it, I don't think. I'm too proud of that, actually. But the weird part is like they... Oh, I see. They wrote there... a to the 2n plus 1. Oh, I see. Okay. This is me saying equals a to the n, but that's like not true. Okay, well, it's on VOD. If I really want to see that beautiful equation again. So a to the 2n plus 1. So like that's what we're plugging in. It's gonna be 2 to the what? 2 to the n? No, 2 to the 2n plus 1. Right, so like... Nope. No, what the heck? This is worse. When k is 1... 1 times 2 times 3 times 4... Ours is not that. Ours is like 2 times 4 times 6 times 8. It's like 2 times n factorial. But it's not that. It's 2n plus 1 factorial? This is driving me up to the wall, in fact. This is the only thing I can think of. I just tried to save it again. I don't know how you would say... Okay. Hear me out. Okay. So a to the 2n plus 1 is... So 2n plus 1 equals 9. So n is going to equal, in this case, 4. And say, so 2 to the 4th. I see how it is. a1 over... Okay, the factorial is still weird, so it's 2 times n factorial. Okay, that... And then, yeah, minus 1 to the n... I guess? Yeah. Okay, good. We did that. Now, maybe I can define this one if I define it in a equals 2n. So in this case, n equals 1. Okay, or sorry, I will do it for a6. N equals, so 2n equals 6, n equals 3. I don't know. Because it's... Oh, wait, they didn't write theirs like that. They just wrote it like 1 dot like this. Here, okay, so we do have 2 to the n times a0 times negative 1 to the n. And they just did this. 3 times 5 times, I guess 1 times 3 times 5 times 2n minus 1. I just wrote it like that, which I feel like is a cop-out. I feel like that's a cop-out. That's not a factorial. I mean, I feel like there's a way you can express that in a factorial that's nicer, you know? Like an odd factorial. Something about that is it's like an odd factorial would be an even a regular factorial divided by an even factorial, but we don't have an even factorial either. I guess that's fine enough. I mean, what was the question asking? Did it just ask for the solutions? I think it asked for the solutions and the radius of convergence. But that means we did one, gamers. We did one. Let's go. I can actually find the radius of convergence very quickly, but let's just write this out. So I guess y1 equals the sum from n equals, where does our sum start? I guess it's gonna be a1 plus, be like a1. Oh no, sorry, 1 plus sum from n is greater than or equal to 3. Yeah. Of 2n a1 over 2n negative 1 to the n. Now, I guess this is 2n plus 1 is greater than or equal to 3. Because we're saying that, yeah. Is that right? Yeah. This is so scuffed. This is so scuffed. Don't look at me. Don't look at me. It looks so bad. Ugh. 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 I have to say like times a1. Everybody's favorite. Everybody's favorite. How does that look? How do we feel about that? What's the approval rating on that? I would say low. I'd say very low, in fact. I would say that sucks, in fact. I'm not even re-indexing it or anything. Nah, just don't worry about it, bro. I put an A1 in there, don't put an A1 in there. So put the negative 1 to the n out here, jeez. Am I a heathen? Yeah, don't mind me, just writing out by hand my 2n minus 1. It's like I need a... What's the sigma for multiplication? Does anybody know? I feel like there's a small chance someone would know. There is something like that, right? I like how mine just got bigger as I went across. There we go. Okay, well, that's that. And then for the radius of convergence, okay. 2x and 4. I think it's just both of them converge forever, right? Or do I actually have to put this sum into a ratio? There's no way I'm doing that. There's 0 way I'm doing that. There's 0 way I'm putting this in a ratio test. Find the radius that are min. Yeah, the radii of convergence for those two. Oh wait, no, it has to be less than or equal to 1. That's what it is. It's like limit as x approaches infinity, I guess. 2x has to be less than or equal to 1. X has to be less than 1/2. Absolute value of x. So radius of convergence is 1/2, I think. Because if x is bigger than 1/2, then we don't converge. Okay. Okay. We've made an attempt. It's probably close enough, I think, to something that's right, where like I'm not too worried about it. Although I wouldn't be surprised if he grades this one. He doesn't grade all of them. What was this? Oh. Okay. We'll weather the storms. Let's take a look. You know what? Let's do 3 actually. This one I will actually copy. Here we go. 3. Okay. So you see we're given a recurrence relationship. Let's just start by re-indexing it. And just for my peace of mind, n minus 2 plus 1 is n minus 1. Actually gonna do this, because I think I kept forgetting this term when I did this before. Okay. So we have n squared minus 4n minus 4 minus 7n plus 14 plus 10 an minus 2. And then we'll do one more time to clean it up a little more. Alright, what is this? 11n and then plus 20. Yeah. We get 20. Oh, we can actually factor that. And that might factor nicely. Put that over here. So 20 is this going to be n minus 10, n minus 1. Oh, and look at that on the bottom. We get n minus 1. Get that out of here. A, n minus 2. Look at that. That is pretty beautiful. Very simple. All right. 5 and 7. All right, so for A2, we get -8 times A0. I'm gonna leave the computation till later. Not because I have any issue with computation. Definitely not. -7 times A1. Okay, so that's -7 times 7. That's -8 times 5. A4 was -6 times A2. -8 times 5 times -6. Yum. Numbers. -5 times A3. 7 times 7 times... I'm not seeing a pattern here. But I guess we can keep going. Or... Yeah. Yeah. Wait, is that right? N minus 2, yeah. I don't know why I was second guessing myself there. A4. Okay. We got some numbers going on here. Not really sure why they're happening, but this is confusing. That should not be A3, that should be A5. I feel like there's no, it looks like there's like no pattern is the thing. What is happening? This is a bad one. Maybe he just wants us to write out, oh, also, sorry, this should be A2, A0, A1. Maybe he just wants us to write out, like, the first couple non-zero terms, which would be here. It would be about there. I mean, this equals what? Negative 40? Is that right? Yeah. No. Yeah. Yeah. Negative 49. I can't do this in my head anymore. Let's see. Okay. 8 times 5 times 6 is 240. I feel like I just have this like sense of feeling that I'm doing this wrong. 245. This times 4. Would it be that times... No, then that times 2. Look at... Hi, how's it going? Ipsum Wacky Stove. Good name. Sorry, this is like the most calculation-y this has been. So this is... Okay. This is 8 times 6 times 4 times... Sorry, negative 8. I guess it's... times negative 2, that'll be times 0, times 2, times 4. And this one will be... And then all of this obviously times our A0. And then this will be... negative 7. Negative 5 times negative 3 times negative 1 times 1 times 3. I guess. That's a pattern. N minus 10 is such a weird little pattern though. Whoa, I dropped my pen. Ooh. I don't know if I like that. It's back to that like... Wait, but it's times 0, so it just stops after a point. Right? A0 just stops. Wait, that's so weird. A0 is literally only 4 terms. Again, unless I did something wrong, which in that case... Maybe this one is also supposed to stop. Because he said write it out in its entirety, which, if they both stopped, you could. So it'd be 5... Huh. The other one won't stop though, will it? I guess maybe I just write it out like... What do you say? Write out yx completely. Is there only one? Wait. Did I forget to do times a to the n? Oh no, I didn't. A to the n minus 2. I did that. This is so wacky. I mean, I guess I could just say... But I also don't know, because this would be... Oh, well... I guess he wants us maybe to add them together? Like y to the x equals... Maybe what, negative? I'm gonna say a0. Negative 8 x minus 6. No. As sum. N greater than or equal to 2? Well, what do we say? We could say 2n, but factorials don't really do that well with negative numbers. I mean, I can just write, well, I don't want to write out all that. It'd be negative, I guess it'd be negative 8x plus negative 8 times negative 6 x squared plus negative 4 times negative 8 cubed. This is bad though, is the thing. I don't like that at all. It's so long it doesn't fit on the whiteboard. And then plus a 1, and then we have to do a sum. There's no way, because you don't have it. So how do I do a factorial of this? I guess I could split it up by saying like add this and then do the factorial there. For n is greater than... Where does that start? Let's see. So this is 3, 5, 7, 9, 11. N greater than or equal to 11 would be n factorial. Well, 2n, 2n. That's scuffed. Oh, I don't like that. I don't like that. You know, it is what it is. It is what it is. Yeah, sometimes I think you just gotta cut your losses. And that is where I'm at. So like the thing that I'm just a little confused about is I feel like I'm doing them right. Which is why it's weird. Minus, and then I can just do minus. Yeah. Are my parentheses closed? Yep. There you go, everybody. Our classic answer. Whatever that is, I didn't even multiply it out. Not that I would need to, but like, why? I mean, I guess I could check. Let's check my factoring calc. Let's put this into a solver real quick. And we'll see if I factored it right. That's always a good place to start. Symbolab, simplifier. Never really a bad thing to do, just to check if you did your algebra right. Let's see, n minus 2. I mean, I'm pretty sure I did. If I couldn't do that, then I would be a little... But I'm sure, lo and behold, it'll be like, you did the whole thing wrong, and then it actually works out when you do it, and then I'm gonna be like... Ah. Okay, I hit enter. Whoops. N minus 1. Did I actually do that wrong? Wait, plus 4. Oh my god. Oh my god, I actually did it wrong. Are you kidding me? No. No, I actually did it wrong. No. Oh my god, I actually did it wrong. Oh my god, I actually did it wrong. Okay guys, I have to retire. That's the effective end of my math career. I can't do that anymore. I'm legally not allowed to because I said that -2 times -2 is -4. And I have to retire now. The government is telling you. That's so sad. Anyway, it's fine. I'm not that sad. I'm glad because it'll probably make more sense when I do it out. I guess I should probably try to do this one. That's kind of goofy. So with the 1 over x, the 1 over 1 minus x cubed, I just need to make sure I did this right. Because so this is a question I'm asking for a power series representation of a function, but to do it through manipulation. And I thought I did it right, but I'm not quite sure. Let me pull up Desmos. Because I just want to make sure I do my integrals right. You know? It's boundless, please. From 1 minus x... Oops, 1 minus x quantity cubed. Because, you know... Oh, it's not gonna let me... Oh. I might not like it if I try and do an integral. Yeah, probably not, huh? Yeah, undefined integral from over the... Can I just do a regular ass integral, please? Can you graph me the output of this? Graph. One, maybe I can do 1 to infinity. Undefined. Oh my god. Okay, fine, I'll just do, okay. Integral, okay. Me when I get my basic calculus wrong. 1, or so x, literally 1 minus x. It should be, right, like 2, like negative 2. Wait, am I stupid? Manual integration. Wait, that's 3. I didn't do negative 3. Oh my god. I was like, no, there's no way I was that bad at integration that I flipped it. 1 over, wait, did I actually? To the minus 1. 2, oh, 1 over 2, wait, 2, it should be 1 over 2. Is that true? Wait, let me think. When you go power rule, yes, it should be 1 over 2. Oh boy, oh boy. Okay, it's actually not too bad. That's just a constant, so like hopefully that didn't really mess with me that much. Where did I even put that? What was I doing here? What was happening here? Excuse me? Why did I write all that out? Did I just forget to put in the 1/2 also? Where am I? What was I doing? Oh, it's, oh, I see. Yeah, so, okay, what I was saying was this... We're trying to figure out the power series that this is equal to, because it's cubed, right? And we know that 1 over 1 minus x is going to equal, like, the power series of x to the... x to the n. This is a geometric series. I think. Did I... Been, more than a year since I did this, and now I have to be able to do it on command. Oh, the gold gears are turning. Was I doing? That's linear deformation. Oh, I put it over there. Like, where did I put my... Oh, that's my CE. No, that's... Yeah, that is my CE, maybe. Maybe when I linearly deform. Okay, there's a recall note in here somewhere, I believe. Recall? I wrote a recall? I didn't, apparently. Maybe I did. I remember thinking, psh, I'll remember that, and then I definitely didn't remember that, so... You know, good for me for writing a recall, if I did write it one. I did. Okay, yes. Yes, 1 minus x equals the power series of x to the n. Woof, okay. We did the basic thing, we remembered vaguely. Yeah, so if we're trying to figure out... So we know that this is the integral of this times 1/2. I mean, I guess I could just say this times 2. So we're trying to figure out if we have 1 over 2, 1 minus x cubed. Then if we turn 1 over 1 minus x, not x cubed, lol, 1 over 1 minus x. We turn that into a power series, then we can, you know, take the derivative and stuff. So this is just gonna be that. It's just negative. Just gonna stuff the 1/2 in here somewhere. I'm a professional. I'm not. I'm really not. Okay. Do I do it too? Why did I take an x squared out? What was I doing there? Oh, I didn't take it out. That's just what it was multiplied by. 1/2. And this one also needs a 1/2 because they both are that. So then I put this in and that goes to there. I guess they're both, I could just say the whole thing is multiplied by 1/2. Does the 1/2 really matter? Sort of. Sort of, I guess. We pull out a term. Why did I pull out a term? Oh. I think wait, what the heck? Why did I do that? This is wrong. Oh, I think that's what I got stuck on. I was like, how do I do this? I pulled a term out of the wrong one, I think. Okay, let's do this. Let's do this properly. Okay, so we need to reindex this to n. So we'll have this the same, plus... Okay, so if we need to go n, we go up 1. Oh wait, no, that's why. That's why this was -1. That was weird. I don't like it, but like, I mean, it's right. I thought I had gone the wrong way. It turns out I had gone the right way, and it's just weird. I can reindex this one. I can pull out a term for this one. Oh, wait. No, I have to pull out 2 terms for this one instead. That's what I was doing wrong. So plus... Okay, we're going to pull out the n-1 term. So that's going to be -1 to the 0 times x. X to the -1 times 0. It's 0. And we're also going to pull out the... Oh, I see. It's going to be... n is going to be 0 also. Plus 0. And then... Oh, wait, we're at 0. It's... Okay, I could reindex it to n. Oh, I should have them both be... Yeah, okay. I'll have them do this. Okay, plus 0. Plus 0. N greater than or equal to 1. That just makes our lives sort of nicer. N times 1/2. Don't remember what I was trying... Wait, was I... Did he literally just ask for a power series representation of this? Okay, good. Because I'm doing that. And it's radius of convergence. Okay, okay, okay. And this one is also n greater than or equal to 1. X to the n times n-1. Cool. Now we can just combine these. Yippee! Equals n greater than or equal to 1. Okay, so we have -1 to the n times n minus 1 plus -1 to the n. What if I just pulled out a -1? Just for fun. Times n plus 1 times n times 1/2. Actually, both of them have the 1/2. Oh, yeah, I did the whole thing. The 1/2 out there. I mean, I guess that's technically it. I can make it a little nicer by saying 1/2 I guess we do n minus 1. Wait, how would I do this? -1 to the n times n minus 1 minus n minus 1? These n's cancel out? Whoa, wait, this is so clean. Wait, so it's gonna be like -2. So we can say like, this just goes away, and it's another minus, so it's gonna be -1 to the n plus 1 times n times x to the n. Okay, that's as clean as I feel like it's gonna be. I feel like I maybe messed up somewhere because it's too clean. It's too nice. I feel like I don't deserve that. Maybe we do. All right. What's our next? Okay, we've gotten 2 done. This one, I don't like this one. I don't like this one. What if I text my friend and say, hey, so, do I even have her number? Oh no. Oh no. Wait, let me see. Nope. Okay. I can't do that. Alright, well, so 3 is kind of also scuffed. Wait, no, 3 is my shame. 3 is my shame. Oh god. Okay, well, what if I just redid it? What if I just redid it? I think that's what we're gonna have to do. Then we're just gonna have to redo it. And I'm really not too particularly pleased about that. I can't believe it worked out so nicely when I messed up. Wait, what's 28? 28's 7 times 4? Wait, we can factor that, but is that good? I don't think so. Have I tried speedrunning? Math? Yeah. It's hard. It's not for the faint of heart. I hope this works out. I hope that works out so much better. Please factoring, please save me factoring. So I don't have to do as much calculation. You put a fake timer on the screen? I could do that. How long is the timer going for, though? Wait. Oh wait, until I finish? Oh god, that's gonna be like long. Wait. I'm getting there. Oh, there it is. Until I finish the problem? Math 100%. Oh, until I finish math. Until I find out all of math. Okay. Fine, we'll do a speedrun. Here, wait, let me put on some better speedrunning music. This is definitely not speedrunny enough. What's a good speedrun? Oh, what's like the Mario Galaxy speed run song? There's like a this one? Yeah, that's pretty speedrunny. This is like terrifying. Okay. Oh no, it's like gonna give me... What do we think? This one or do we think this one? This is gonna be like me putting numbers in my head. Yeah, this is like more intense. No, the other one's more fun. This one's more fun. Okay, we'll do this one. Alright, when I hit the go button, I'll do it. Wait, let me clear off my screen first. It's gonna give me precious seconds wasted if I am not aerodynamic enough. Okay, ready? Okay, ready? Okay. I'm losing everything. Okay, what do I need? A0 equals 5. A1 equals 7. A2 equals... Okay. And minus negative 5 times minus 4. Negative 2 over minus 1. Negative 1 times a and minus 2. A0. Okay. 3 equals negative... negative 4 times negative 3 over negative 2. A1. A4 equals negative 3 times negative 4 over negative 3. I'm trying to like figure out which one to... Oh, that's not A0. A2. Okay, so that's negative 3 times... Oh wait, they cancel out. I'm gonna leave them uncancelled. Negative 5 times negative 2. A0. A5 equals negative 2 times negative negative 5 over negative 4. A3 equals negative 2 times negative 5 over negative 4 times negative 4 times negative 3 over negative 2. A1. I did pull up the exponents kit. That's insane. It's the factoring. The factoring is good times. Okay, negative 1 times negative this over... This is the craziest thing to speedrun because it's literally just numbers. Okay. Negative 3 over negative 5 times A4. Oh god. Negative 3 times negative 4 times negative 5 times negative 2. It's gonna get to 0 soon. So that means A8. So A9 plus equals 0. But A8 is gonna equal, what, 1? 1 times minus 8? Wait, what? And minus 4. Oh no. Oh no, I've not been doing this right. Oh no, oh no. This is minus 1. Wait, this is 0. Oh wait. Wait, what is the timer? What is it's the timer's going. Stop. Stop. It's What literally? What is this noise that's happening? I don't know what's happening. Is it this? Is it? I don't know what's happening. I don't want to. It's this. I can't restart it though. Okay, wait. You have to. Oh no. Oh no. Oh no, my run. Okay, wait. Okay, wait. We have to pause. We have to pause. It won't stop ringing. What is making that sound? What? Oh, it was this one. I actually started to think it was a bomb. Okay, never mind. The run's not lost. Oh wait, it is lost. Okay, sorry. We'll have to you'll have to add the 3 minutes and 10 seconds. Okay. Back. Nothing stops me. Oh, I messed this up. Wait, no, so A4, A4 plus equals 0. Wait. Okay, they both go to 0. Okay, get out of here. A5 is gonna be 1. 5 minus 4, 5 minus 7, 5 minus 1 is regular 4. It's regular 3. That's regular 2. That's negative 1. Wait, 3 minus 1, 2. Wait, 2 minus 1, this is a positive 1. What the heck am I smoking? Okay, that's fine. 1, A8 this is already 0, and that's 0. Okay, we only need to do these 5. Wait, and A6 is already done. Okay. Okay, so negative 10 times 5. This one is 4 over 2. So 50 times A0. This is 2. I don't know if my professor is gonna be too happy about how this looks. This is 0. Oh wait, this is so easy. What? Oh my god, if I had just done it right the first time. Okay. So 10 over negative 4. He doesn't know. He didn't start the timer? No, I didn't start. Wait, it's going. It's just not, it's there. It's there. Don't worry. I'm good. I'm not. So okay, 10 over 4, 12 over 2, that's 5 over 2 times, it's both negative, it's fine. 6 equals 5 times 3 equals 15. Equals 15 times 7, what's 15? No, I'm not in that. No, clear. 15 times 7. 105. 105, no, that's that. Wait, no, A0. Wait, no. That's just 50. A1. 7. Okay, that's it. Write it out completely. Okay, so 5 plus 7x plus 50x squared plus 7x cubed plus 105 x to the 5th equals y. There we go. Wait, no, I didn't hit the stop button. There we go. I scrolled down. Okay, that was, what was that? That was 2 minutes. Sorry, you're gonna see that plus, no, 10 seconds plus 2 minutes. I can stop the evil music now. She did not like that. 3 times 60 plus 10 plus 2 times 60. $361 divided by 60. Okay, 6 minutes and 1 second. That's what I got. Pretty good. That's pretty good, I would say. We're definitely What am I? Holy speedrun chat. I don't know if that's right. I think it's right. I knew they both had to go to 0 at some point, but I didn't know how long it would take them to go to 0. That's so funny. That one makes a lot more sense than the other time we did it, when one just wasn't gonna go to 0. Let's see if that's right. I feel like you should lose points in the speedrun if it's not right, you know? You should have to keep going. Okay, so minus 1, 28. Minus 7, minus 4, okay, so minus 5, minus 2, 1, that's good. 10 times 5, that's good. Let's see, 3 minus 7 is minus 4. 3 minus 1. Okay, these are still gonna be minus. These ones aren't gonna be. I mean, it's not a minus 0. Do that. Easier to. Oh, the speedrun thing is still in the corner. It's just a calculator thing. Yeah. Let's see. 4, 2, 2, oops, 2. Uh-oh. 2 times 7 is not 7. Oh. That's definitely minus points. That's definitely minus points there. That's sad. See, that one's 0. I guess I should probably say that A6. Wait, I probably should say how A7 is 0. Right, so A6 equals something times 0 times A4 equals 0. And A7 equals 0 times n minus 4. That's pretty win. See, when the pressure is on, I can do things fast. Do I do things fast all the time? That's like me in an exam. That's how fast I go in an exam. Except I'm a little slower than that, probably. Checking if I wrote the right things. Okay. So -1/2 of A3. I don't think should be 105. What was I writing? Oh, I see. That one's also wrong. This one's wrong. Is gonna equal -7. Whoops. To be fair, I got A3 wrong, but it shouldn't have been that large. I'll have to check it later though. Alright, I think on that note, we did most of it. I have to ask him, so I don't have to ask him about that. I do have to ask him about this, because that's weird to me. That one's fine. 4 was fine, for sure. And 5 was... Oh, 5 was a little weird. 3 I'll have to check, 4, it's fine. I have to ask him about... it's fine. It's probably good enough. I don't know, maybe it's some... Oh. No, okay. Wait a second. Oh no, it's not that. I thought it was sine and cosine, because this one is this sine? 2n over 2n... No, because it's 2n factorial, like 2n quantity factorial. This is 2 times n factorial, so that's not... This is very close to cosine, though. I think. Well... Yeah, that's pretty good. Pretty good for 2 hours. It's like most of the problem set. Thank you for witnessing my speedrun of the first math problem speedrun ever. That's a lie, actually. There's definitely been people who speedrun math problems before. I'll be back sometime. Let me think. Maybe Tuesday? Yeah. Probably Tuesday. With, I would have to guess fluids, but maybe not. I don't know. Kind of depends. Alright, well, thanks everybody for hanging out. It was, great to see y'all. And I'll be back later. Have a nice day. Bye.